Okay, good morning. Let us see today the second unit PLC basics. So already we saw about the use of relay, how we are using the relay. So let us see once again about the relay. Then we will go in detail about the PLC. Okay. So if you know the logic of relay, then it is easy to learn PLC programming. So that's why I am insisting you to learn this relay working. Okay. Now see in this uh, slide, you can see here left side top this symbol. The left side of this symbol is having contact. That's the point number 4 and 2. And right side of this image 1 3. This is belongs to the coil. So basically, what is this one? If you give power supply to this coil, if you give the power supply to this coil, automatically there will be electromagnetic. So because of the electromagnetic, then the contact will try to get close. So this is the okay basic working of relay. Isn't this already we saw in the first unit also? Fine. Like that, if you see the how the relay used to connect with a PLC or with any digital controller. So you can see the bottom left side, a transistor has been used to connect relay. So that means what I have done, they use 12-volt power supply to what I say to trigger the relay. In fact, the relay can work in the 12-volt power supply. Fine, like that. Okay. So what have they done here? According to this circuit, the relay coil has been connected in series with a NPN transistor. So it means what? The transistor will work as a switch. So you should know how a transistor can work as a switch. For example, transistor can be used as an amplifier. It can also used as a switch. So you should know how a transistor will work as a switch. Fine. Then it is easy to understand it. Fine. So anyway here, according to this diagram, so there is a transistor and the transistor collector has been connected to in series with the relay coil. Emitter has been connected to the ground. Then base is connected to signal of a digital controller. So that means base is getting the input signal from a digital controller. So this digital controller can be a microcontroller or the microcontroller which is used in a PLC. Fine, like that. So in this circuit, just along with the relay coil, along with the relay coil, there is a contacts. You can see this contact. Okay, I mentioned NC, NO, common. Already we discussed about what is normally closed, normally open, like these things. Okay, so the same thing has been used here. So what's happening here? So when there is no power supply, the common contact, that is the common, okay, this moving contact will stay with the NC. Will stay with the NC. If relay coil get powered, then automatically what will happen? Because of the electromagnetism, this moving contact moves towards NO. Okay. So when the relay coil get electromagnetized, okay, then the common moving point will move towards NO. Okay. So that is the thing. Fine. So this is the working of this one. The same thing has been explained the top right side also. You can see here also same circuit. Okay, so but in the contact they have shown only one contact. Okay, and the standard symbol which is used in the drawing, automation drawing, so that you can see here the bottom. Okay, the right side. Right. So I hope you understand this slide. Okay, how a relay works. Now here you can see the real-time relay image meta used in the project also in last 2 years, like in the PBL, like the blue color relay. Okay, so basically relay means what is the pin will be there. There will be power supply to the coil. So if you want to give the power supply to the coil, then there should be two wire. That is okay. Coil here also you can see coil. Here also you can see coil. So these two pins are connected to the power supply. Fine. Then if the relay is having two contact like a NC NO, so you can find this NC NO. Then there will be moving contact is called common. So it will try to move between NC and NO. So that is the common. Okay. So basically there will be 5 pins in the relay. That's the thing. Okay. That similarly you can see the same type of electromechanical relay bottom. Okay. Here you can see here. So this is the relay coil, and here you can see the contact. In the image you can see the contact, the top and bottom. The top, the moving contact is touch with the contact. So it is what? It is normally closed. Okay. And bottom one is okay free from the moving contact. So it is normally open like that. Okay. Then these are the symbol you can see. Okay. Single through, double through. Single through, double through contacts. Okay. So this is about the okay symbol. So I hope you understand this. What is the relay working? Any doubt? Okay. So we can move the next slide. Then contactor. You might have heard about contactor. Might have heard about contactor. So what is the difference between contactor and relay? Basically both are same only. Okay. Basically both are same only. So that's a single phase contactor, 3-phase contactor. Okay. Single phase contactor, 3-phase contactor. So single phase contactor means it is used for the single phase power supply, and working will be like more or less like a relay only. But then what is this one? The single phase contactor. Contactor means generally it is used for the high power application. High power means basically high current application. Maybe if you are using more than 5 ampere, okay, if you are using more than 5 ampere, then you will try to use the contactor. If it is system, that means if you have to switch on switch off like a 1 ampere 2 ampere, then you can use the normal relay. But if you are going for more than 5 ampere, then you can go for the contactor. So it can be 3-phase contactor or single phase contactor. Fine. So I hope you have already heard about it. Okay. So this is the image of the contactor. So basically you can see here, this is the 3-phase contactor. How do you say? Because you can see here 1, 2, 3. Similarly top also 1, 2, 3. Okay. So that means this contactor will on for 3 points at a time. Okay. Then how will you get on? By giving the power supply to the relay coil. So when you will give the power supply to the relay coil, here you can see the side. At the side, you can find this point. Okay. Here you used to give the power supply for the relay. Fine. So if you give the power supply to this one, automatically this contact will get closed. Okay. Then you can switch on the 3-phase power supply. So that is the contactor. I hope you understand. Now this is, we can see the comparison between relay and contactor, how it works. More or less same. Okay, things will be more or less same. You see the relay, if the coil get energized, this moving contact move. But whatever this contact, it is for single phase. Okay, having NC NO. But if you see in the contactor, If the relay coil get powered, then these three contacts get closed at a time. So it means used for the three-phase power supply. Fine, like that. So this is between the relay and a contactor. What are the different types of relays are there? What are the different types of relays are there? Like electromechanical relay, this is the what we saw in the previous slides. Solid state relay, then hybrid relay. Hybrid relay means it is a combination of solid state relay and electromechanical relay. Then reed relay, electrothermal relay, polarized and non-polarized relay. These are the different types of relay they are using. What I shown here, what I listed here, the contacts, these relays. These are for automation purpose. These are the automation purpose. You already studied in the power system, or you may study in the switchgear protection. So that relays are different. They are used in the substation, like a distance relay, okay, ohms relay. Then, like there are different types of relays are used in the substation. Okay, so that is used for the protection. That is used for the protection. Fine, and this is used. These are used for the automation purpose. These are used for the automation purpose. Okay, so that is the thing. Okay, so already we saw about the electromechanical relay. Now let us see about the solid state relay. Solid state relay means what? Basically, solid state relay is totally made up of. It is totally made up of semiconductor. Like as I mentioned before, a transistor can be used as a switch. A transistor can be used as a switch. The same principle they are using in the solid state relay. Now you can see here. Okay. This is the, according to this image, here you can see this is called basically LED. You know the symbol of LED? Okay. So this is the LED. For example, if a diode comes without this arrow mark, if a diode comes without this arrow mark, then it is normal diode. Okay. If a diode comes with like this arrow mark, then it is giving the light output. So we can call it as a LED. Okay, like that. Then what is this? This is called light activated semiconductor device. Light activated semiconductor device. It is a power electronic device. It is a power electronic device. So you might have heard about it. What I say, SCR, triac, like that. Isn't? So like that, it is a power electronic device. So this is the power electronic device which will activate by the LED, or we can say with activated by the light operating, okay, device. For example, if a transistor, in the transistor BJT, in the BJT, so by giving the signal to the base, the transistor will on or off. Isn't? Like that, in the SCR, there will be three terminals. What are they? In the SCR, there are three terminals. Gate, source, gate, drain. Try to see SCR, what is the pin number? You are telling wrong. Okay. There is a anode, cathode and gate. Pardon? Yes, anode, cathode, gate. Okay. Like that. In triac, do you know triac? What is the difference between triac and SCR? SCR used to control DC device. Triac is used to control AC system. Okay. In the triac, what are the terminals are there? Terminal 1, terminal 2, then gate. Like that. Okay. So be okay. So try to aware about the power electronic devices. They are very, very important in the automation nowadays. Okay. Most of the control systems are coming with the pure solid state. Okay, like that. Okay. So like the what is happening here? If you give, that means if you, okay, give the signal like a light to this power electronic device, then this power electronic device will on. Like it's a contact. Now in electromechanical relay, there is a moving contact. There is a moving contact. But in solid state relay, there is no moving contact. Already told BJT can work as a switch. But inside the BJT, is there any moving contact? No. The same thing, okay, in solid state relay. Then why do you use this one? Wherever you want high frequency of switching. For example, okay, you want to go in terms of kilohertz, 1000 times per second, 500 times per second. Okay, the switching can be like a 500 times per second, 100 times per second, 200 times per second. Then they will go for the solid state switching. Okay, then they will try to use the solid state switching. So like that, this is the, okay, solid state relay. So any doubt? Any doubt? So let me stop here up to this one.